Alright guys, so this video is on blood typing. So a little reminder about blood typing. You're still going to separate it. These are the genotypes. The phenotypes are either O, A, B, or AB. Remember for O, the only genotype you can have is little I, little I. For A, there are two potential genotypes. So there's big I, big A, little I, which is heterozygous. Or you could have big I, big A, big I, big A, which is homozygous. For B, it's very similar to A. You could have I, big B, little I, which is heterozygous, or you could have I, big B, I, big B. For AB, there's only one genotype, which is IA, IB. If you're getting confused by these I's, just think of this as, cover up those big I's and think AB. Here, cover up those I's, we've got B, cover up those I's, we've got B. This is an example of multiple alleles because there's not just dominant and recessive, there's actually I, so little I, there's A, and there's B, okay? So when we're setting these up, we have a father who is type A, heterozygous, so he is going to be this type A, not this type A, and we have a mother who's type B, heterozygous, which is going to be this one. So dad is type A, heterozygous, so he is IA, little I, okay? So he's a carrier for O, but he's A. A and B are always dominant over O. And then we have a mom who's type B heterozygous. So we've got I, big B, little I. So I would recommend always putting A before B and the capital I before the lowercase I. It'll just make more sense of things. So here we've got I, A, I, B. Here we've got I, B, little I. Here we've got I, A, little I, and we've got little I, little I. So before I even look at the percentages, I'm going to go through this. Here we've got AB. Here we've got B, here we've got A, and here we've got O. So let's look at these percentages. What percentage or fraction do I have of little I, or type O? I've got 25%. What percentage do I have of A? Now remember, A could either be big I, big A, little I, or it could be big I, big A, big I, big A. Well, I've got 25% A. B, again, we could have big I, big B, little I, or we could have big I, big B, big I, big B. Again, 25%, and 25% AB. Let's go down to another problem, similar layout. And I know this is a little confusing. Guys, this is the same thing as a Punnett square. If it helps to scribble out that little corner, you can. So here we've got a father that is type O and a mother that's type AB. So there are no options here. So dad's type O, so he's going to be little I. And mom is AB, so she has to be big I, big A, big I, big B. So we're going to put this together. Got big I, big A, little I, big I, big A, little I, big I, big B, little I, and big I, big B, little I. So let's do the exact same thing. We've got A here that's heterozygous, A here that's heterozygous, B and B. So what percentage of O do we have? 0. What percent AB? 0. So we've got 50% A and 50% B. Last but not least on this page, we've got a father and mother that are both AB. So both of them are going to be AB. Remember, each parent donates one allele, and that's why we're going to separate these and not put AB in the exact same square. So we're going to go ahead and fill those out. We've got IA, we've got IA, IB, we've got IA, IB, and we've got IB, IB. So here, great example of homozygous for A. We've got AB, we've got AB, and we've got B. So what percentage of O? 0. What percentage of A? We've got 25%. What percentage of B? 25% or a quarter. And AB, we have 50%. So what I would recommend doing when you're doing these problems, immediately write down these because I'm not going to give this to you on an assessment. You need to know that there are 2 different options for A and 2 different options for B. Flipping to the back side. These are going to be some ones where we're going to have to draw on a separate sheet of paper because I do not have a lot of room on this sheet. So what are the 2 genotypes possible for an A blood? Well, A is a phenotype. So the 2 possible genotypes would be IA, or we could have IA, little I. What genotype does an AB person have? IA, IB. What does a person with O? Little I. And what are the 2 possible genotypes for type B blood? Same as type A, just plugging in B. And that's a review from the front. Okay, so let's go ahead and do these 6 problems. We have a man with type AB blood that is married to a woman that also has AB blood. Use a Punnett square to determine what percentage each of their children will have. So we're going to go over here. We're just crossing two AB people. So we've got Punnett square, IA, IB, that's one parent, IA, IB, fill it on out. So let's count this out. We've got an A here, we've got an AB here, we've got AB here, and we've got a B here. So we have 0% with O blood, we have 50% with AB blood, we've got 25% with O blood, and we've got 25% with A blood. That was an easy one. That's like from the front. Number 3, a man with type B blood. When I say genotype BB, all I mean is IB, IB. And he is married to a woman with type O blood, so we know that she's little I. What blood type will their children have, and what is the genotype? Let's go ahead and cross them. We have a dad that's homozygous for B and a mom that is O. Well, they're all going to have the exact same thing. So they're all going to have blood type B, but the genotype would be IB I. Okay. For number 4, when I say O, AO, that just means IA I, BO, not body odor, IB I. Nobody's listening in class right now because nobody's marked out what I just said. All right, so we're going to cross these two. We have I, big A, little I. And then we have I, big B, little I. And we've got IA, IB. And then here we've got IB, little I. Hey, KJ, 1 second. Here we've got IA, little I, and we've got little I. So here we've got type O, here we've got B, here we've got AB, and here we've got A. So percentage of A blood, we've got 25%, or you could put a quarter. For B blood, we've got 25%, or you could put a quarter. For I, we've got 25%. And for AB, we've got 25%. Number 5 is the one that people will get stuck on periodically, so I want to talk through this. So for number 5, a woman with type A blood, but I didn't tell you what kind, is claiming that a man with type AB blood is the father of a child who's a type B. So we've got a paternity test issue. So mom does not know if she's homozygous for A or heterozygous. So she could either be I big A, or she could be I big A, little I. Potential father is IA, IB, and the kid is type B. So the kid could be IB, little I, or it could be IB, IB. So we need to find out if he could be the dad. First of all, if mom is IA, IB, is there any way we could get a child that's IB, IB? No, because you have to get one allele from mom and one allele from dad, and neither one of these has B. So this cannot be the kid. The kid would have to be IB, little I. Now, let's think about that. Could mom donate an IB? No, but mom could donate a little I if she's this. Could dad donate a B? Yes, he could right here. So we know that mom could not be this one. So let's go ahead and cross them and see if we can get this kid. If you didn't know how to fill it out the way I did, you could have also done 2 different crosses, with mom potentially being this genotype with this dad and mom being this genotype with this dad. So we're going to go ahead and cross. Mom is heterozygous for type A. Dad is AB. So this would give us a type A kid, so that's not possible. This would give us a type A kid. This would give us a B kid, but this could give us a B kid. So could the man be the father? It's possible. So yes, but the mom's genotype would have to be IA, little I. If it was IA, that couldn't be right. If you guys are still struggling on this, come and see me. Thanks.